Hello. Now we are going to look at construction 10. And in construction 10, we are going to construct a triangle where we know all three side lengths of the triangle. So looking at that in geometry language, we have the symbol for a triangle is something that looks like a triangle. So we have the triangle with the corners or vertices of the points A, B, and C. So the corners of the triangle are called its vertices, its vertexes, and they're just the points A, B, and C. And we know all three side lengths. So going from A to B, the distance from A to B are vertical lines on either side of the capital letters for the points, means the distance between the points A and B are vertices A and B. And that's going to be 5 centimeters. And we know B and C and A and C as well. So we know all of the distances between our points. So we know all of the distances between the corners of our triangle, or the vertices of our triangle. Now, when we want to draw a triangle at any stage, we're going to draw a couple of quick sketches first. And they're not going to be detailed or particularly accurate. They're to give us a feel for what this looks like, because this is just a string of letters and numbers. We need to draw a picture of this and know where everything goes. So the very first picture I draw is not with straight lines or anything like that, and I don't attempt to get the side lengths correct. All I'm going to do is draw something that looks like a triangle, and I'm going to label the corners A, B, and C. B and C. And then I'm going to put in my side lengths so I know what they're supposed to be. So the distance from A to B is supposed to be 5 centimeters. So A to B should be 5. B to C should be 7. And A to C should be 4. So my first diagram doesn't attempt to get the side lengths correct at all. Now that I know that, I'm going to say, well, the longest length should be from B to C, the shortest length should be from A to C, and then the middle size length should be from A to B. Now all I'm going to do is draw a slightly bigger line for the bottom one, and then I'm going to say I need to have a slightly longer bit going for A to B, and then a slightly shorter bit going for A to C. So A, B, B, C should look more like that. So I draw my first one without any attempt to get any side lengths or anything correct, just to let me put the numbers next to side so I can get a feel for what should be bigger and what should be smaller. And now this is a little bit closer to what I want to end up with. Again, this does not need to be neat. It needs to give us a very basic feel for what the thing should look like. What should be big, what should be small. Now I'm going into it with a much stronger sense of what the thing is supposed to end up looking like. And if I end up with bigger and smaller sides I don't expect, that'll jump out at me now that I've done those crude sketches. Now, what I want to do is start to draw in my side lengths. I'm going to start with BC because it ended up on the bottom line here. It's nicer to start with a horizontal line a lot of the time. Just gives us more of a feel for an anchoring, if you will. So what I'm going to do is start down here, and I'm allowed to use a ruler for this. So I can just draw a line across, starting at 0, and I'm going to go across 7 centimeters. So stop it neatly as we can at 7. So that's going to be going from B to C. So I'm just going to take a second and put that in. So I'm going to go from there to there. Is going to be my point B, B, and C. So now I have an anchor for where they're supposed to be. And now my problem is, how do I figure out how to go up like this? I couldn't just use a ruler and start drawing points that were 5 centimeters away from B to try and get up to A, because I've no idea how that's going to link up with the line going from A to C. So how do I get a consistent distance away from a point? Well, I would use my compass for that. So what I'm going to do is grab my compass, and I'm going to open the compass up to 5 centimeters, which I have actually already done. So I would just open it up until it's set to 5 centimeters, and then keeping it at 5 centimeters, I'd bring it down to my point B, and I would rotate it around. I know it's going to be somewhere up around here. I can be quite generous with my arc, but I don't want to make it a big circle. So I know that all of the points on this arc are going to be 5 centimeters away from B. So A has to be somewhere on that arc. And I also know that A is 4 centimeters away from the point C. So I go back to my ruler. And I say, okay, well, that's supposed to be 4 centimeters away from the point C. So I need to change my color so I can just see where all of these different bits are coming from. And I rotate that around and draw in a nice big arc. I want to see these arcs in my final construction. I don't want to hide them. Now I want to put a point where those cross each other. So I've put a point there. That point there is going to be at A, because it is 5 centimeters from B and 4 centimeters from A. And there's only one point that meets that criteria up here. There would be another one down here, but it would end up with the same triangle. So if I kept that arc going down, this arc going down, there's actually another identical triangle to be created by having a point A down there below the screen. But for our purposes, we don't need to worry about it. Now we have our points, and all we have to do is connect the dots. So I am going to go through my point there. Go through my point here. From B up to there gives me my side AB. And then I want to move over. And I want to draw in my line here, going from C to A. And now I have the 3 sides of my triangle drawn in. So I can label this. My construction is mostly done. I want to label that point as being A. So I now have a triangle with a side length of 7 centimeters, a side length of 4 centimeters, and a side length of 5 centimeters. So I know that this length is 7 centimeters. I know that this length is 4 centimeters. And I know that this length is 5 centimeters. And I can look back to my original sketch, and I was a little bit small with this side, but other than that, I had a better feel for the general proportions, and I've left in those arcs so it's clearly visible where my work is coming from. Now, this is the only triangle that you can draw with those 3 sides. There's no way that you can change the proportions of this triangle, and there's no way you can change the proportions of this triangle, because if you know all 3 sides of a triangle, you create it uniquely. There's only one way that this works out in physical space. This is one of the reasons why triangles are so strong from a construction point of view, like engineering construction point of view, and it is also important linking to a different part of our course where we are doing congruencies of triangles. How do we know that 2 triangles are identical to each other? Well, if we know that they had the same 3 sides, that would guarantee that they were identical to each other, because there's only one triangle that we can draw that has side lengths of 5 centimeters, 4 centimeters, and 7 centimeters. All we could do was rotate that triangle around. We can't change its shape or the proportions of its shape at all. There is only one triangle that ends up being drawn with the side lengths 5, 4, and 7. Or if we know any 3 side lengths of our triangle, we can draw it uniquely. And that is why we can use side, side, side as a way to show that 2 triangles are equal or congruent to each other, because we can draw the triangle with that information and we can draw it uniquely. So that is what we need for now.